let's go ahead and get started. I know some people are still filing in, but that's okay. Just a couple quick housekeeping notes. We are recording these, so if you have any cell phones or other devices that are going to make any noise, if you could just turn them off or turn them into silent mode for your neighbors and for the recording as well. That'd be great. So my name is Scott Schnall. I'm a principal technical writer on the Exchange team at Microsoft. And among other areas, I'm responsible for the documentation around things such as virtualization. I'm part of a working group inside of Microsoft called the Exchange Virtualization Working Group. And it's a group of stakeholders across the company that work with the Exchange program managers to figure out what our supportability and testing and what our story for virtualizing Exchange is going to look like. So I'm very excited to be here to present to you what we have come up with so far. Some of this might not be new to all of you. We've actually been doing virtualization with Exchange for some time, starting with 2003 and then up to 2007 and of course with 2010. How many of you are virtualizing Exchange today? And for those of you with your hands up, how many of you put your hand down if it's not on Exchange 2010? Okay, so just a couple people are virtualizing Exchange 2010 today. So almost everything here should be new for everyone, with the exception of maybe the beginning terminology that we'll start out with. So we will start out with some terminologies just so we sort of level set the expectations. Then we're going to talk about our support policy and guidelines so that everybody knows what is supported and what's not supported. We'll talk about things like our deployment guidelines, our sizing guidelines, our high availability guidelines. And then we'll end up at the end of the hour with some scenarios that we think make good sense for virtualizing Exchange. We only have an hour, though, so we might not have time for questions at the end. But if that happens, I'll be able to step off to the side while the next presenter is setting up. And you can also see me tomorrow at my sessions or at the booth as well. So let's start with some terminology. Again, some of this might not be new to you. If you've been virtualizing, particularly with Hyper-V, you're probably going to know what all these terms are. But in case you haven't, it's important that you understand what these terms are, because not only will we be dealing with them in the presentation, but of course you'll be dealing with them when you leave here and go back and start to virtualize. So I want to level set so everybody knows what I'm talking about when I say things like root machine. What do I mean when I say root machine? Well, the root machine, also known in some hypervisors, is the parent machine. That's the physical hardware. That's the hardware on which either the hypervisor is running on directly, for example, in the case of Microsoft Hyper-V, or there's an operating system on there, and that's got a hypervisor in it. For example, Windows Server 2008 with Hyper-V. That's the bit that goes on the physical hardware. Now, inside the root machine, we've got these guest machines, and they're not really inside them, but the parent-child relationship works fine. We call them guests. And the guest is your Exchange server or your SQL server or your directory server, whatever you're virtualizing in that environment. Okay? Any root machine can have multiple guests, and it's very common to take a root machine and deploy multiple guest machines on it. Now, every hypervisor out there uses storage as well. Now, in the case of Hyper-V, we use what we call virtual hard disks, VHD files. The terminology may be different in other hypervisors, but the concept is still there. The use of some sort of virtualized storage mechanism is still there. So VHD is one type of hard disk that you can make available to your guest machines. And you can actually make it available for the guest operating system. It could be used for, in the case of Exchange, guest databases, guest log files, etc. But it's storage that's available to you. It doesn't have to be actual physical storage. If you wanted actual physical storage, that's a second concept known as the pass-through disk. Okay? That's a disk that is connected to the root machine. So the root machine sees it as its storage. And then that storage is assigned to only one of those guests. Okay? And pass-through actually has some benefits. It's faster storage. Okay? It's not virtualized storage, so you don't have the virtualized stack on top of it. It's actual physical storage. It's just being dedicated to one guest. Now, it makes the experience faster, but it does limit some of the portability of that guest. If you're doing anything like root-based failover clustering or sometimes what we call hypervisor-based high availability, that is where your guest machines float between different root machines. You can't do that if you're using pass-through disks because pass-through disks are connected to only one machine. Okay, so anytime the guest moves away, it leaves its storage behind in that case. Now, all of these guests, the VHD and obviously the pass-through disks, are supported. Now, a couple other terms you need to know. There's actually Well, there's really three types of VHDs, but we'll just concentrate on the two types that we have in Hyper-V. One is the fixed VHD, and the other is a dynamic VHD. And based on the animation, you could probably figure out the difference between the two. A fixed VHD has the space pre-allocated to it. Okay, you haven't filled it up yet, but it's pre-allocated on the disk. It's guaranteed to be there when you need it, and it's the initial size of the VHD file when it's created. A dynamic VHD, though, that starts out tiny, tiny, and then as you fill it up, gets bigger and bigger and bigger until it finally expands to whatever maximum size you set it to. Now, there's a couple problems with the dynamic disks. One is that you have no guarantee that disk space is going to be available for you to grow into. Okay, nothing's being pre-allocated, which means if you've got your databases on one of these and you're growing that database over and over and over, it may not be able to reach the actual size that you anticipated. It may be fixed at a smaller size because the underlying disk can't expand anymore. The other problem, and this in the case of a heavy transaction-based application like Exchange is a bigger problem, the fact that when you do have a dynamically expanding disk and it is time to grow it, there's a pretty substantial performance hit with increasing the size of that file on disk. Okay, it's pretty trivial to fill up a file that's already expanded. We're just filling up space that already exists. But now if we have to tell the disk to go get more space and then expand the file on disk, that's a much, much bigger hit. Okay, so because of the performance hit, because of the potential that there might not be space available, we will not support these dynamic disks in production. You can use them in your labs and in your test environments, but if you're going production with Exchange in a virtualized environment, you have to use a fixed VHD and not a dynamic VHD. Okay, a couple other things. Every time you build a guest machine, there's going to be some ancillary files that go with it. You're not just going to make a VHD file and allocate some resource to it and call that your virtual machine and have it come up. There's all these other files that go along with it, things like the virtual machine state file. Okay? Now, you may not be using this ever in your environment. Okay? This file is there so that if you do have to move one of these guest machines from one root machine over to another root machine, that the state can be saved in this file. This file can be moved over to the other machine and reopened and brought back into the same state. Even if you don't use that feature, that state file is still going to exist. It's going to consume a little bit of space on the operating system of the root machine. Now, there's other files, and this one's a biggie. The temporary memory file. Again, you're going to have one of these files, one of these bin files, for every guest machine you dole out. And it's going to be equal in size to the amount of virtual memory you give that machine. So, if you're deploying an Exchange server and you give it 4 gigabytes of memory, you're going to have a bin file in the file system of the root machine equal to 4 gigabytes. If you give that machine 8 gigabytes of memory, the bin file for that machine is going to be 8 gigabytes. So the amount of memory that you give your Exchange guest machines will directly affect the storage design of your root machines. So keep that in mind. You've got to have plenty of space to account for these large files. And then the last term I want to talk about is that third type of VHD. This is called a differencing VHD. Sometimes we call it a delta disk. Sometimes we call it a differencing disk. It's the same type of concept. You have this base disk that perhaps a bunch of machines are using, and all of the changes to that base disk are being written to separate files. Okay, you don't have to duplicate all the things that are the same across all those disks. You just have one master disk that has the commonalities, and then you write the deltas somewhere else. And that's a great way of saving disk space, and it's also the technology used behind the scenes when you're doing things like using snapshots in Hyper-V. Now, when we say snapshots, we don't mean a VSS snapshot. We mean the Hyper-V snapshot, where it's taking a copy of your virtual machine, making a delta of it, and taking what's ever changed forward into the new image. How many of you have worked with snapshots in Hyper-V? Okay, great. Snapshots in Hyper-V, I think, are a great thing. Now, we don't support them in production, which means we don't support the differencing disks in production. But using something like snapshots are awesome for labs. Okay, that's all I do in my lab is use snapshots. Once I'm done with Exchange, maybe doing a demo of a DAG or whatever, I can take all the machines, shut them down, and revert the whole topology back and start from scratch before Exchange was even installed, so I can make a fresh org every time. It's a great thing to have inside your lab environments. Not supported for production, though. Okay, So let's talk about what things are supported, because we do make frequent updates to our support statement. So even if you've only read it once or a couple times, you will want to check back frequently because we are constantly refining it and updating it. So in terms of what we do support, it's pretty simple to find a hypervisor we support, because it'll either be Hyper-V or any hypervisor that is part of our Server Virtualization Validation Program, our SVVP. Okay? It's a logo and certification program, and it's also a support program. So think of it as kind of like the HCL for virtualization. Okay? It comes from the Windows Server Catalog site. So you go to windowsservercatalog.com/SVVP, and there it shows you all the hypervisors that we've tested and included as part of this program. Now, why is this program important? Yes, it's important for the testing. It's very important that both Microsoft and third-party vendors have a good, solid understanding of how their hypervisor is going to behave. But the real benefit of this program is a direct benefit to you. And that real benefit is the joint support agreement that's a requirement to this program. Okay, so it's not enough for a third party to come and have their hypervisor validated in our test room. Okay, they have to then sign a joint support agreement. And what that means for you is if you call them or if you call us, we now have a joint support agreement where we can work with them jointly on the call. Okay, in the absence of that support agreement, all third-party product support to us is effectively troubleshooting a black box. We don't have any exposure into any third-party products. We don't have code for third-party products. We don't have the source for third-party hypervisors. That's owned by separate companies. But when we have one of those joint support agreements, when we get to a situation where we think it's a bug in the hypervisor or we're not sure if the hypervisor is doing the right thing, we can get a support engineer on the phone brought into the call as a support resource, and we can continue troubleshooting the call without having to hand the customer off or without having any finger pointing going both ways, wondering who's to blame here. Now everybody works together trying to solve whatever problems you might come up with. So that's a big plus. And that's the reason you absolutely want to get either Hyper-V or something out of the SVVP. Now, beyond those requirements, obviously the guest is going to be Exchange 2010. Beyond those requirements, though, you'll still have to meet all the system requirements for Exchange 2010, which means the OS for that guest is going to be 2008 SP2 or Windows 2008 R2. It also means that you'll only be virtualizing 4 out of the 5 roles: Mailbox, CAS, Hub, and Edge. It also means that the storage is either going to be VHD, a SCSI pass-through, which is going to get you the better performance, or iSCSI, which is also supported. And we'll talk about iSCSI in a little bit. And if you want, you can also use the Exchange High Availability construct known as a Database Availability Group, or DAG for short. You can also do those inside of guest machines as well. However, there is a caveat to that. That's what that asterisk up there means. And the caveat says that, yes, you can do DAGs in a VM, but not if the VM is also configured for root-based failover clustering or root-based HA. Okay, that's the caveat. We'll support DAGs as guest machines in a VM, but you can't have the root also be clustered when you do that. We'll talk about that in a bit. So that's the first thing that's not supported. I already mentioned that snapshots and delta disks are not supported in production environments. They are great for labs, though, and I would strongly recommend that you use them. You might be wondering why we don't support them in production. So what happens when you take an Exchange server on a time travel trip back in time? Does it still work? Yes or no? What do you think? Just shout it out. Yes or no? No. Yeah, a lot of no's. You've probably done that, speaking from experience maybe. Those are quiet no's, like you've done that before. Okay? That's right. It won't work anymore. Every Exchange server on the planet, while running, has stateful information on it. Okay? That stateful information is also time-based. If you take that one single server in isolation and you move it back in time, you've effectively taken out of the other Exchange server space-time continuum, and it will no longer function. Yeah, yes, I'm using Star Trek terms to make it seem fun, but it's not fun, and it's actually an impossible situation to get out of. And if you take it back in time and bring it up and let it try to connect to the organization, in doing so, you'll make irreversible changes that will prevent you from ever bringing it forward again. Effectively, you'll destroy the machine. What that means, though, is that in order to use snapshots in any topology in your lab environments, you have to roll the entire topology back. Okay? That includes your directory servers and maybe your DNS servers too if you've made DNS changes. It's not enough just to take a single server back in isolation. Because of that, we don't support the snapshots in a production environment. Okay, some other things that we don't support, the unified messaging role. How many of you are using UM? Okay, not too many hands, so not too many people will be affected. UM, when you think about it, is a fantastic invention. Okay? Yes, we all know it does voicemail and Outlook voice access and things like that. But when you think about it, it's really a collection of technologies that have been put together to create this UM role. Okay? Things like speech server technologies in there. Things like real-time communications protocols are in there and so forth. And in fact, it's the real-time communication protocols themselves that are not supported by the RTC team in a virtualized environment. They just don't have the processing power we need in order to get that real-time voice sampling that you would need when somebody's leaving a voicemail. So because of that, because the RTC group doesn't support their components inside a virtualized environment, and because we use those components in the UM role, we can't support the UM role in a virtualized environment. Now, I will tell you from my own personal experience, if you want to demo UM, it will work in a virtualized environment for you. You can make calls, you can test things, you can set everything up. You just can't run it in production in a virtualized environment. Some other things you need to be aware of is there is a ratio between the virtual processors that you'll assign to your guest machines and the number of physical processors that are in the machine that you should not exceed. And that ratio is 2 to 1. 2 virtual processors for every 1 physical processor. Okay, so what does that mean? Physical processor, typically now we're counting them as cores. So let's say you've got 2 4-core processors in there for a total of 8 cores. That means you can give out no greater than 16 virtual processors to all of your guest machines on that box. Whether they're Exchange, whether they're DCs, whatever, you can't go over that 2 to 1 ratio. And 2 to 1 ratio is actually pretty big. Okay? It's a pretty big ratio, enough where you could get, provided the box was sized correctly, you could get a lot of VMs on a single box and still hand out a lot of memory and still not exceed this virtual proc ratio. But just be aware that is a support boundary. We found that after you go over the 2 to 1 ratio, performance of Exchange goes down considerably. Okay? So don't go over that ratio. The other thing you won't want to do, and actually we had a customer that we just heard of was doing this, and you don't want to do that. You don't want to take the root machine, which should be doing nothing other than servicing guest machines, and install heavy server-based apps onto it. Okay, so for instance, don't put Exchange on the root machine. Don't put SQL on the root machine, or SAP, or Oracle, or SharePoint, or any other server-based applications. Now, management applications are okay. Backup software, antivirus software, some sort of software updating software, those kinds of things. But nothing else belongs in that root partition. Nothing else should be running on that, because the root should be dedicated for servicing of the guests. So that's also a support boundary. And then the last part here, which is actually really specific to Hyper-V because it's Hyper-V's support stance. So if you're not using Hyper-V, this won't apply to you directly. But Hyper-V does not support doing a VSS backup of the root by going directly through those pass-through disks. Okay, that's not an actual backup. For one thing, it's not going to reach into the guest. It's not going to be an Exchange-aware backup. It's not going to authenticate any logs or anything. But Hyper-V themselves do not support this, and because they don't support it, we don't support it as well. So you won't be able to back up any data going that way. Now, how many of you are still on 2003 and 2007? Okay. Fair number, almost everybody. So I wanted to include these, even though this session was supposed to be about 2010 and virtualization. I know some of you, to get to 2010, have to figure out what you're going to do with 2003 and 2007. And for some of you, there may be opportunities to do things like server consolidation or use some sort of physical to virtual tool to virtualize your existing infrastructure. Maybe you need to make room in your data center by eliminating a lot of the machines that are running legacy versions of Exchange, perhaps to make room for new machines that are going to run Hyper-V or some other supported hypervisor. So the support statement is pretty similar with 2007. The thing to remember with 2007 is we didn't import RTM. Support came in with Service Pack 1 for Exchange 2007. So you have to have at least Service Pack 1 are available, but that only got you as far as Windows Server 2008 SP2. If you wanted Windows Server 2008 R2, then you're going to need Service Pack 3 for Exchange 2007. Service Pack 3 adds support for those later operating systems. And a lot of people want to go to R2 because there's some potential savings there. There's perhaps a 20% reduction in power consumption when you're virtualizing. That's an attractive reason to go there. And of course, it's the latest code. That's a very attractive reason to go there as well. Exchange 2003, that's only supported on Microsoft Virtual Server. We did not take support for that and bring it forward into Hyper-V or any of the SVVP platforms. That's still going to be Microsoft Virtual Server. Now, no other versions of Exchange are supported in a virtualized environment. So if you happen to be on 2000, 5.5, I'm not going to ask you to raise your hand. But if you're there, you know who you are, and you're probably cowering under your sheets every day. But you can't virtualize that, although you probably don't care about that at this point. And no other virtualization platforms are supported as well. Okay, so we're only looking at Microsoft Virtual Server, or in the case of the 64-bit counterparts, Hyper-V or SVVP. That's the support boundary. Now, we've made it real easy for you to check on this stuff. Okay, I've told you what the support policy is, but as I said, we make frequent updates. Okay, that policy could change, it can evolve, it can be clarified, and we do that all the time. In fact, we're in the process of making some updates in terms of using dynamic memory, for example. So in the next month, you'll see an update to that TechNet article. But the TechNet article is the single authoritative source for Exchange. Now, the SVVP program, they have a great tool that you can run, and we recommend that you run that tool, but you'll always want to check the results of that tool against our TechNet article to make sure that you're following the Exchange support guidelines. Okay? Because sometimes the support guidelines are different based on the product that you're running. We may be doing things a bit differently from SQL or differently from SharePoint and so forth. So you want to make sure that you're always checking the Exchange TechNet article for the latest info. Okay, now let's talk about sizing guidelines. Anybody getting ready to deploy in a virtualized environment? Wow, okay, great. Well, if you haven't done your sizing, this will help you out. Couple things to keep aware of, though. Exchange, for instance, is not virtualization aware. It has no idea it's being installed into a guest machine. So it's not going to behave any different, and that's a good thing. The setup experience is going to be the same. Any of the tuning algorithms or throttling that we have built in is going to operate the same. It's not really going to be too different from an Exchange perspective. However, while hypervisors might be free, the virtualization stack itself is not free. And it's going to add overhead and some management complexity to the system. Okay? Now, in our test, we showed it added anywhere from about 10 to 13% extra overhead. And that's going to have to be accounted for in the sizing of your root machine. And depending on what hypervisor you're using, there may be other things that you have to do from a sizing perspective. For example, in the case of Hyper-V, all guest I/O is serviced by the root machine. Okay, that means any I/O that happens in a guest, whether it's network I/O, whether it's storage I/O, any kind of I/O that's happening in the guest is going to be serviced by the root machine. Okay? What that means, in the case of Hyper-V, is that the root machine has a bit more work to do. Okay? You're going to have to add additional resources into the root machine to allow it to account for this extra overhead. So you might have to throw an extra network card in there so that one network card's not getting overwhelmed. That's particularly true if you have multiple mailbox server guest machines on the same root machine. You may have to add extra storage capacity in there as well, or perhaps a faster I/O controller if you're using pass-through disks. So keep that in mind. There's a layer of overhead that's going to come with it. The other thing is that the workload costs themselves tend to increase as well. That's a little bit more difficult to characterize, though. I can't really give you any numbers as to what that's going to be, because it's going to be different for every organization. Okay? For one thing, you'll know you'll have the extra management workload of the patching that's involved. You can't just patch root machines and guest machines the same way you might do physical machines. There's this order and staging that you'll have to go through to sort of cascade things around to make sure that you're not taking down critical production services when you're trying to patch these things. So that's what we mean by workload costs increasing. Now, virtualization, the fact that you're virtualizing is only going to affect the design of your root machine. It's not going to directly affect the way you design your guests. You're still going to take the same design principles and the same tools you're using today to do your sizing and design and apply those in a virtual environment. Okay, so that means using jet stress the same way you're using it today to check the storage system, and that means using load gen the same way you're using it today to check the rest of the system. Okay, if you're not using those two tools, you're not sizing Exchange correctly. Now, one thing to keep in mind, and this isn't true just for sizing, this will also be more important as you go through the operational life cycle and you're doing monitoring and performance collection. There's this nuance to collecting performance data inside the guest machine. Okay, what's interesting is the guest has one view of the performance counters, and the root machine has a completely separate view of the performance counters. Okay, so what does that mean when you're measuring the CPU in the guest, and it says it's 64%, and you're measuring the CPU from the host perspective, and it says it's 22%? Which one's right? Anybody want to take a guess? Which one's right, guest or host? Oh, that's a good guess. One's a fraction of the other, so one is 60 and the other's 20. Good guess, not correct, but a good guess. I like that you were thinking. Anybody else? Okay, well, the fact is they're both right. Okay? Because the performance counters that are being measured are relative to the unit that's publishing them. The way time slices or time is sliced up in the CPU from the root machine skews the way time gets sliced up from the child machine. Okay, so the performance counters that you're seeing in the child are completely and 100% accurate from the child's perspective. Performance counters that you see in the root machine are completely accurate from the root perspective. Okay, so you're sort of going to have to pick and choose which counters are most meaningful to you and where you're going to measure them from. The good thing in terms of the application, though, in terms of Exchange, well, the Exchange counters will only exist in the guest machine. They won't be in the root machine because you're not installing Exchange into the root. You're installing it in the guest. So largely, you're going to do almost all of your performance monitoring from within the guest machine. That's where you're going to get the best counters, the best representation from the guest's point of view as to what's happening in terms of workload. And that's where you want to do your measuring and collection from. Now, if you're interested in seeing the Hyper-V performance counters, or if you have an application that you put on the root machine and it's publishing performance counters and you want to see those, you can go ahead and collect data from the root machine. The root machine is the only place you'll see the Hyper-V counters. You won't see those in the guest. So it depends on really what you want to monitor, but don't be put off by the fact that the CPU is not going to add up or match between your hosts and guests. That's just due to the nature of time slicing and actually partially due to the laws of physics as well. Okay. So for Edge and Hub, let's talk about those. Obviously, our physical guidelines, if you're deploying in a physical environment, those remain unchanged. The things to watch out for in the virtual environment are, one, our processor core ratio. Okay, remember, we still have the 2-to-1 ratio for all of the machines. This is a separate ratio counting the number of, in this case, hub transport server cores against the number of mailbox server cores. And the ratio that you'll use here will depend on whether you're using antivirus software on your hub or you're not using antivirus software on your hub. So if you are using antivirus software, then you only need 1 hub core for every 5 mailbox cores. Okay? If you're not using antivirus software, you need even less. You'll need only 1 hub core for every 7 mailbox cores. Although we do strongly recommend that you have antivirus software there. But if you don't, because perhaps you've got some other mechanism that's taking care of that for you, the ratio becomes a lot less when you're not using antivirus software. Now, the ratio in terms of virtual machines to physical machines is also similar. So if you're doing everything in a VM, you'll need 1 hub VM for every 5 mailbox VMs that you have. Okay, it's a very, very straightforward and easy to remember ratio. These, by the way, these are our sizing guidelines. These are not support requirements. So if it turns out that the workload that you've designed and you're deploying for doesn't really work out such that you have that many mailbox servers, then you're going to have a lot lower number of overall servers as well. Okay, so this is just showing between hub and mailbox right now. For client access server, the physical, again, it's going to be the same, very similar to what we had at Exchange 2010 RTM. The difference here is going to be 3 CAS virtual machines to every 4 mailbox virtual machines that you have. So CAS is a little bit heavier in terms of its workload now. We've actually done a lot of work, and we've even moved the mapping and directory endpoints out of the information store and over onto the client access server. Okay? So as a result of doing that, CAS is doing a lot more work now. It is the connection endpoint for all Outlook clients, for example. Okay, so because CAS is doing a lot more work, its needs are very close to the mailbox server needs. Okay, you see 3 to 4 here, you see 3 to 4 here. We want 2 gigs per processor core. That's a fairly beefy type of box that we're talking about. Okay, so that's why the ratio with CAS is so much higher. If we were doing this exercise in Exchange 2007, it would be 1 CAS for every 4 mailbox. Okay, but now it's 3 CAS for every 4 mailbox because of the workload increasing in CAS. Now, how many of you are attracted to the idea of co-locating server roles, like CAS and Hub on the same machine? Okay, just a few hands went up there. We actually think that makes really good sense in many cases. You know, there's a lot of advantages in co-location. You save yourself an operating system license. You save yourself an Exchange license. It's fewer machines to manage, fewer space occupied in your server room, which means less power and cooling, et cetera, et cetera. So it can be very attractive in some cases. Not every customer is going to lend itself well to being able to separate out those roles. Not every customer is going to lend themselves well to being able to co-locate those roles. It's really going to be determined by your workload. But if you are co-locating them, notice there is a change. It's a pretty big change. If we look at the VM ratio for just CAS, it goes from 3 to 4, 3 to 4 here. Now it actually drops down when you're co-locating there. Whoops, let me back up here. Now it actually goes to 1 CAS Hub VM for every 1 mailbox VM. Now when you co-locate, it's a 1-to-1 relationship between the two. Okay, it's not enough just to have 1 to 3, 1 to 4. It's going to be 1-to-1 in this case. Okay. So what does that mean in a co-location when you've got all these cores? So if I have an 8-core box and I want to co-locate, I can get 1 mailbox, 1 CAS Hub combo on there. Okay? I can double that with 16 cores and triple that with 24 cores. Really depends on the sizing of my root machine. However, keep in mind when I'm doing scenarios like this, and we'll talk a little bit more about that in a minute, when I'm doing scenarios where I'm having all of these on the same single root machine, that is going to limit my high availability options. Okay, for instance, I wouldn't be able to have all these 3 mailbox servers in a DAG because they're all in the same root machine. And if that root machine goes down, it's taking all the DAG members with it. Okay, so that wouldn't be high availability there. But if you're not interested in Exchange high availability and you just want to pack all the Exchange servers you can into a big iron box, 24 cores will get you 6 really beefy, robust machines. Now the mailbox server, that's the core role. That's where all of the work is happening outside of CAS and outside of the transport. Really the thing to look out for here is generally you're not going to be giving more than 4 virtual processors to the mailbox role. There are some hypervisors out there that will allow you to assign more, but generally 4 virtual processors is going to be the top of what you do. The other thing though is you may need to adjust this. Okay, because mailbox should still be designed based on your message profile, the number of messages sent and received each day, and the average size of those messages. Okay, that's what we mean by message profile. So even though we're saying 16 to 24 gigabytes, you might have a very heavy message profile that might be at the upper end of 24 gigabytes. You might have a very low message profile that might take things down to maybe 8, 10, or 12 gigabytes. It really depends on your workload, and so you're still going to follow the formulas that we have for sizing the mailbox role. Now, the thing to keep in mind, though, is that the virtual processor is not the same as the logical processor. There's not a 1-to-1 mapping between the physical CPU and the individual virtual processors that you can hand out. Okay? Again, there's some overhead involved. In the CPU side, we see about 10% overhead. There's, in other words, a 10% performance drop between a physical processor and a virtual processor. To account for that 10%, we recommend that when you're comparing physical to virtual, you want to drop the virtual mailbox count by 10%. So what does that look like? It looks like this. Over here, we've got our message profile. And by the way, if you're wondering where the words are, like where's light, medium, heavy, very heavy, we've actually dropped that vernacular with our profiles. We came up with too many profiles and we didn't have enough words to describe them. So we dropped using the words, and now we just use the numeric value for the profile. So this is the total number of messages sent and received, and here we're assuming an average message size of about 75K. Yours might be bigger, yours might be smaller, but this is a good place to start. So if I were doing 300 messages a day on a physical server, I could get 500 users on that, okay, per core. But because of that 10% overhead that's involved with virtualization, if I go virtual, I need to drop 10% on the boxes or 50 mailboxes, so I can only get 450 mailboxes on that same sized equipment. Okay? So virtualization is going to shave stuff off the top for you right off the bat. Okay? So keep that in mind when you're sizing your mailbox servers. For some customers, they might look at their existing mailbox servers and say they're already so well utilized, I'm not going to virtualize them. It's not worth the 10% drop. I might virtualize CAS and Hub because they don't have that penalty, but mailbox is going to do fine on physical hardware. And that's perfect. That's a very reasonable way to go. Okay, I said we were going to talk about storage. Remember, we talked about those different kinds of storage, one being the SCSI pass-through. Now, we do have the strong preference for using SCSI pass-through on your databases and log files. The reason for that is simply you get your best performance out of the pass-through disks. Okay? They're not virtualized disks. There's no layers on top of them that are making them act like storage. They are actual storage. Okay? And the actual storage is always going to be faster than virtualized storage. So that's going to be our recommendation. Now, some of you might be using iSCSI disks. iSCSI disks are also supported as well. The thing to keep in mind with iSCSI disks is that they have certain networking requirements. There's certain configuration settings that you'll do on a network card when it's an iSCSI network. Things like TCP offloading. Things like jumbo frames is very important in an iSCSI network. Now, when you're virtualizing iSCSI, because it's network-based and it's using nothing more than the target and the initiator, you can use iSCSI either directly to the root, or you can go in through the network and use iSCSI within the guest. The choice is yours. Be aware, though, that when using iSCSI within the guest, you don't always have that full-featured network stack. You may not have the ability to configure jumbo frames, for instance. You might not have the ability to do that TCP offloading. Okay? So you may be limited in what you can do. And if you don't have those features, you want to choose another solution. If you can't do isolation and jumbo frames and all that stuff with iSCSI in the guest, then you want to go iSCSI to the host and make it available some other way as a pass-through disk, for example. But if you're using later hypervisors, Hyper-V R2, I believe, supports jumbo frames in the guest. And I know there's third-party hypervisors on SVVP that also support that as well. If you had that support in the guest, then you probably prefer to do that in the guest because it increases the portability of the storage. Okay? Then the storage can follow around the guest if your guest is also portable. So keep that in mind when you're using iSCSI. Let's talk about HA. How many of you are interested in high availability for your Exchange infrastructure? Great. Hopefully I'll see you tomorrow at the deep dive in the design guidelines session. But in terms of high availability, when you compare it with the virtualization stack, there's some pretty big differences. Now, generally, when we're talking about high availability and we're combining virtualization into the mix, you really only have two choices. One is going to be the root-based failover clustering. We'll talk about that first. And then the other is simply going to be Exchange's built-in native stuff, which we'll talk about in a minute. So what do we mean by root-based failover clustering? Well, it's pretty self-explanatory. We mean you're using failover clustering on multiple root machines to get high availability for your guest machines. Okay? Or so you think. Because the reality of it is root-based failover clustering isn't providing HA for your guests. It's providing HA for your roots. Okay? If you want something that's HA for the guests, you're going to have to look at a different solution, like perhaps the guest itself has a native solution like Exchange does. But when you're using root-based failover clustering, and this is virtualization platform independent. This isn't unique to Hyper-V. It could be a third-party hypervisor as well. This is high availability for the root machine. It is not high availability for the guest. It's not going to do things like protect you against all of your hardware failures or protect you against network failures. It's not Exchange aware either. Exchange doesn't know it's there. The solution itself doesn't know Exchange is there. There's nothing duplicating your data. There's nothing that's going to help you from data corruption or data loss. All it's doing is protecting you in case one of the roots has a power failure or some catastrophic hardware failure. That's what you get out of it. The thing to keep in mind also, there's two important things. And I probably should have reversed these bullets because I think the trend is the more important point to make. Okay, the trend with email, what's happening with email, what has happened with email since it started? It's been on this angular trend of nonstop going up. The number of messages we send and receive every day is increasing every day. The average size of those messages that we send every day is increasing every day. Okay? And there's no reason to believe or expect that trend to change or do anything other than continue on its upward path. Okay, so if the trend is towards more email, the trend is towards larger mailboxes. Larger mailboxes could mean a longer recovery time if you don't have something like a database availability group, which is designed for a very short recovery time for all these failures. Okay, if you don't have that, which you don't have with root-based failover clustering, because you cannot combine root-based failover clustering with guest VMs in a DAG, you don't have any of that application level HA. You don't have data redundancy. You don't have service redundancy. So by comparison, with Exchange, you've got a lot of choices. Now, when everybody thinks about high availability, they think about the database availability group. Okay, that's that set of up to 16 servers that can work together and provide you with database level failover in response to server failures, hardware failures, network failures, etc. Okay? And it's a solution in which we use a combination of log shipping plus the Windows failover clustering to keep tabs on the entire system and to duplicate the service and the data so that if part of it goes away, surviving parts can continue up functioning, giving service, providing data, and so forth. And what's even better is it's a solution that can very, very easily be extended across multiple sites, multiple AD sites, and multiple physical data centers. Now, the DAG is all great, but it's only one small piece. It's only the high availability piece here. There's a bigger umbrella that we want to look at. The umbrella we call Exchange Native Data Protection. NP is the acronym there. Okay? That's not just using DAGs and database copies. That's using combinations of other features. Okay? Things like single item recovery. Things like retention tags and retention policies, or lagged mailbox database copies, which are special kind of mailbox database copies that are kept back in time in case you encounter logical corruption and so forth. So you can compare HA to HA, but really when you're comparing the two, you're really just comparing root-based high availability, high HA for the root, with this whole slew of built-in native data protection that understands the difference between a good and bad log file, that knows how to retain item, that protects you against corruption or lost data, and so forth. So to hit that point home even further, I've got some animation that will help illustrate the differences between the two. So, and this is true, by the way, I don't mind pointing out that this same animation and the same concept doesn't just apply to Exchange 2010 and the DAG. It also applies to Exchange 2007 and a solution like CCR. Okay, so if you're using cluster continuous replication in 2007, or you're interested in the DAG today, the concept is exactly the same. In Exchange HA, we've got Exchange and Windows clustering working together. We're heartbeating everything. We're checking the servers, we're checking the networks, we're inspecting log files, we're making sure that the OS, the hardware, and the app are up and running as expected. A lot of robust checks going there. Email messages, they come into the server. Shouldn't be new to anybody. Once the messages are in the server, we create those log files, and we write those log files to the disk, and they get committed to the disk. And in the case of CCR or the DAG, once they're written, they're also shipped over to one or more other copies of the data as well, and everything's maintained on separate disks, so it's done in isolation. If we have a problem on one disk, it's not affecting the copy on the other disk. Now, if something does happen, we've got some sort of failure with one of the members in the DAG or maybe one of the pairs in the CCR cluster, the other one handles it seamlessly. Messages will still come in, we'll still create the log files, we'll still commit them to disk, and if there's other copies out there, we'll ship those log files out to other copies as well. Okay? That's Exchange HA in a nutshell. Okay? That's a very basic look at it. We didn't go deep at all. We will tomorrow. Now, compare that with root-based failover clustering. Where Exchange isn't the physical hardware, Exchange is now the guest machine running inside some other machine that's the physical hardware. Now, there is a live heartbeat that the guest will get from the Hyper-V host machine, from the root machine. The root will know if that guest is still up. It won't know if Exchange is running. It won't know if any of the services are stopped, which is critical. It won't know if any of the databases are dismounted, which is also critical. It won't know if any data is corrupt. It won't know if you've got mailbox database copies in a status of failed. It won't know if your content index catalogs are sick. It won't know if the RPC client access service isn't accepting connections. It doesn't know anything about Exchange. All it knows is, yeah, this guest is on or it's off. And in this case, we'll say it's on. That's it. That's all it knows. The same thing's going to happen. The messages, they'll come into the guest this time, not into the root machine, obviously. And we'll do the same thing. Again, Exchange has no idea it's in a virtual environment. There's no behavior change here. It's still going to commit them. One difference here, though, is this is root-based failover clustering, which means we don't have HA for Exchange under the covers, which means this is the point at which your data stopped. We make one copy of the data, and that's your only copy. If something happens to that copy, all that data is lost. There's no duplicate that we ship logs over to. Now, let's say you've got a live migration situation. You want to do a planned outage here. It's a planned migration. It's an orderly stop of the guest. The guest is frozen, moved over to another system along with that virtual machine state file I mentioned earlier, and then reanimated, thawed out, whatever you want to call it, brought back to life, and it begins servicing it. You know, from the Exchange standpoint, it looks like all TCP connections just got dropped. Okay? So it'll reconnect as possible, and it'll come back up and continue operating. Okay, but that's the plan migration. So what happens if instead of doing a plan migration from here to here, that one just goes away? Well, that's an unplanned migration. There's no opportunity for the machine state to be saved. There's no opportunity to freeze and quiesce activity on the machine so that it can be moved over and thawed out and brought back to life. Instead, it's just like you walked up to the machine and hit the power button. Okay? You're cold booting Exchange at this point. So remember, the root-based failover clustering is only HA for the root machines. It's not HA for the guest machines. Okay? If you want HA for Exchange, you're going to be doing the DAG inside guest machines, and you're not going to be using root-based failover clustering on your root machines. Okay, so let's end up talking about some deployment scenarios, because you might be wondering, okay, I get all the support stuff, I get the guidelines and everything, so show me the scenarios into which it does make sense to virtualize Exchange. And there's several. There's lots of opportunities here if you want to virtualize Exchange. Okay, so think about the smaller remote office. How many of you have small offices, branch offices, remote offices? Just a few hands went up. There are a lot of customers that have these. And these small offices make great candidates for virtualization. Because in some cases, they can actually provide you with up to a 50% decrease in the number of physical servers needed by that branch office. Okay, so here's an example. Okay, over here are the guest machines. We've got 3, 5, 7 guest machines. Okay? Without virtualization, I would be deploying 7 physical machines. With virtualization, I'm only deploying 3 physical machines. Okay? 3, by the way, is the magic number. If you want to do any high availability inside of Exchange, you always will need a minimum of 3 physical servers. Whether you're deploying them on physical hardware or whether you're virtualizing everything, you will always need a minimum of 3 servers. Okay? There's no way to get around that. You can't do it with 1, obviously. You can't do it with 2, even though the smallest DAG you can create has 2 servers. You must have 3 physical servers. Here's why. So we actually have a complete Exchange org here. We've got 2 directory servers, DCO1, DCO2. We've got a co-located hub and CAS that are also, we're using NLB in our virtual environment, which you also can do. There's other load balancing options that are also workable in a virtual environment. Here we're just using NLB. We also have a file server over here. And then we've got 2 mailbox servers, and both of those mailbox servers are in a DAG. Okay, so we don't have any root-based failover clustering. We're doing our HA inside the guest machines in the DAG. Okay, here's why you need 3. Remember, the smallest DAG that you can create is a 2-member DAG. All DAGs that have an even number of members will always use a 3rd server external to the DAG called a witness server. Okay, the witness server is there to provide a weighted vote if it's needed for quorum. And again, come to the HA deep dive and you'll learn all about that stuff tomorrow. But the point is, though, this DAG has a witness server, and that witness, even though it's not a member of the DAG, is needed for quorum. That means the witness needs the same isolationism that each of the individual DAG members have. Okay? Which means each DAG member has to go on a separate root machine. And that means the witness server also has to go on a separate root machine. If we co-located any two out of those three things on the same root machine, and that root machine went down, it would take the entire solution down with us. It would not be an HA configuration. You'd need at least 3 physical servers. Now, let's say you have these 3 physical servers, and you went with blades, and you decided you're going to put your blades, you put them in the rack, and you do this design, and you've got everything separated, just like you see here. The DCs are on separate roots. To give Active Directory some resiliency. The DAG and its witness are scattered across all 3 for resiliency. You've got CAS and hub separated, so one failure doesn't take out both of those. But you've put all of your blades in the same rack. Okay, what's the problem with that? Okay, there's one power cord coming out of that rack. If that power cord comes out, doesn't matter that you isolated everything, it's taking down all of those blades. Okay, so it's not enough just to separate them out into 3 physical machines. You also need to separate them out in terms of power, maybe in terms of cooling, depending on how large your data center is, and so forth. Okay, so this is the base design, but you still have some infrastructure design components, such as where to put those 3 physical servers when you're deploying them. Okay, this is a very basic, simple example. We can get a bit more complicated, disaster recovery or site resilience scenario. How many of you have more than one data center, like a standby or backup data center? Great, great. Well, that's a great scenario for virtualizing. Okay, you can use virtualization inside that data center, get yourself a warm or hot data center without having to have all of that physical hardware there. Okay, so what might that look like? Well, it might look something like this. Okay, we're over here. We've got your primary data center, and this is all physical hardware. We've got a couple DCs, a couple CAS, a couple hub, a couple mailbox. And then over here in the standby data center, we've got just those 3 servers. And again, we've got a couple DCs, a couple CAS, a couple hub, and a couple mailbox. And everything, again, is separated out so that we don't have the same type of service running on the same root. In other words, the DCs are on separate roots, CAS are on separate roots, hubs on separate roots, mailboxes on separate roots. And that's a viable design. But you might be looking at this going, well, I don't see how we're getting site resilience out of this. Well, that's easy. You take the 2 machines that you have up here that are physical hardware and the 2 mailbox guest VMs that you have down here, which are virtualized Exchange servers, and you put them in a DAG together. Okay? And now you're replicating the databases from your primary data center over here to your standby data center. It is okay to mix virtual and physical machines inside of a DAG. Okay? And you might have noticed when the DAG popped up here, because this is our primary data center, this also becomes our witness server. We've got 1, 2, 3, 4, so we need a witness server for this DAG. We put our witness server in the primary data center. Okay, so this is how you're combining Exchange HA plus virtualization to get yourself a nice standby data center that's pretty warm or hot at this point. It doesn't take too much to do a data center switchover in Exchange anymore. Okay, so that's another great scenario. How many of you have ever worked in the military? Okay, just a couple hands. Thank you for your service. If you haven't worked in the military, maybe you've worked in other organizations that use what we call mobile LANs, or sometimes what we refer to as LANs in a box. Okay, think of a rack. Okay, think of a truck rack or a dolly where you have all your servers on this one rack, and they've got all their storage underneath it, and it's on wheels, and you can move it around, and you can load it up into a truck when you need to, or set it up anywhere you need to go. That's what we're talking about when we say mobile LAN. Okay, you just unplug, you ship it somewhere, and you plug it in, and you're good to go, and you've got everything that you need. Okay, in a very compact form. For instance, if these are small blades or small cubes, this is not only lightweight, but it's easy to transport. Okay? But because it's in a virtualized environment and you can get so many guest machines in here, you can provide all the services that that entity or organization needs. You've got your directory servers. You might even have a couple firewalls in there. You've got a database server, management, file services, hub and CAS, mailbox and a DAG. And of course, you could add other application services. Maybe you've got management and monitoring. Maybe you've got some line of business apps. Maybe you've got some special military apps that you're running and so forth. Either way, that's another great place where virtualization can work with Exchange to provide a solution that's unique to that environment. Okay, let's talk about server consolidation. How many of you would like to do server consolidation in your environment? Okay, just a few hands. Usually it's more. Maybe you've already gone through it, but about this time last year, it was a lot more hands, a lot more people were interested in consolidating things using virtualization. I think perhaps either the fewer hands means that people have already done it, or perhaps it means that they didn't have as many opportunities for consolidation as they thought they would. Because it can be confusing. There are some scenarios in which consolidation makes great sense, and there are some scenarios in which it doesn't make sense at all. So let's talk about them both. So where's a situation in which it might make great sense? Well, for instance, if you've got underutilized directory services or underutilized CAS or underutilized hub, those are great examples for server consolidation opportunities. I can take those 3 underused services, the directory, CAS, and hub, and virtualize them. Now I've just got 1 physical server, and out of that, I'm getting 3 different services out of it. Okay, that's a great consolidation opportunity. What's not good, though, is if it turns out both of your directory servers are underutilized, virtualizing them both and consolidating them both onto the same root machine, that's not a good idea. Okay, again, it's going back to getting some sort of availability for these guest machines. If you put both of your DCs, and they're your only 2 on that one machine, and that one machine goes down, well, then all your DCs came down, and then everything's coming down with it. Okay, so that's one place where it does make sense and one place where it doesn't make sense. And of course, the big place people look at is the mailbox consolidation. Okay, they want to take their mailbox servers and they want to virtualize all of them so that they can just jam everything into one as much as they can. Now, if it turns out that all of your mailbox servers are so underutilized that they are good candidates for utilization, you still might want to think twice about doing that. Okay? The reason is, remember, the mailbox server is the core. That's where the mailboxes themselves, the public folders themselves, that's where that data lives. Okay? So if that data is gone or it's not performant, then the user experience is going to be very bad. Okay? So you want to avoid situations in which you're consolidating multiple mailbox servers onto the same root machine. This is not really a good strategy. Okay? Forget about the performance aspect, although there will be one. You're most definitely going to have to add extra resources to this went down this path. But think about the all eggs in one basket paradox here. If you put everything in here and that goes down, that's a large user population. It might be your entire user population, in fact, that's now down and not getting email anymore. Okay? So there's not really good server consolidation opportunities for multiple mailbox servers. There's really good opportunities for non-mailbox server roles, but for the mailbox server role itself, generally you wouldn't want to consolidate that. You might want to co-locate it with other non-mailbox roles in a virtualized environment, like you saw in the other examples, but you definitely don't want to co-locate it with other mailbox roles on that same root machine. That's just a bad practice. Okay, and with that, I'm pretty sure we have time for questions. Let me just do a quick time check here. Yeah, we've got 3 minutes for questions, and I would like to keep it to the 3 minutes because I know there's another speaker who's got to get set up. If you don't have a question, I do want to thank you for coming and also remind you to please fill out your surveys. And if you do have a question, just go ahead and raise your hand, and I'll repeat it because we don't have microphones in here, and hopefully we'll get that answer for you. Thank you.